Hello students, welcome to my class. Today we are going to discuss few questions related to JEE Main exam pattern. Clear friend? So let's start with the topic, that is question answer round, and how to solve the question. Look at what I'm telling. Now look at the question, read the question carefully. I'm giving you a few seconds. A blue colored complex Fe4, FeCN hol 6 hol thrice. A blue colored complex, average oxidation number of Fe is A, okay. Oxidation number of central iron atom is B, yes sir. And the oxidation number of the counter iron atom, this one is central and this one is counter, okay. Wait for a moment. This one and this one, okay. This one is central, this one is counter, that is this one is B and this one is C, okay. We have to find out the value of A, B, C respectively. So let's start how to solve the question. I'm giving you a detailed solution, then we'll discuss the answer. Now let's move here. Solution of this question, look at what I'm telling, listen carefully. The compound here is Fe4, FeCN hol 6 hol thrice. This is the compound. Now it will dissociate like this, 4Fe3 plus, then no need to write plus, you can write like this, 3FeCN hol 6 4 minus. This is the simple case. Now total iron here is 4. Now 4 into 3, okay, and here is Fe is in +2 oxidation state. Do you need to find it out? Find it out. X plus -1 into 6 is equal to -4. Yes sir. X minus 6 is equal to -4. X is equal to -4 plus 6. X is equal to +2 oxidation state. Clear? So 3 into 2, 3 times iron. Total number of irons 4 plus 3, 7. Put here 7. Now multiply 4, 3, 12 and 3, 2, 6. The average oxidation state is 18 plus 18 by 7. This is the value of A, okay. Now what is the oxidation state of central iron atom? Sir, the oxidation state of central iron atom is +2, that is this one is +2, this is the value of B, yes sir. Now what is the oxidation state of the counter ion? This one is the counter Fe and here is +3 oxidation state, this is the value of C. Now we can say that is the answer. A is equal to +18 upon 7, yes sir. B is equal to +2 and C is equal to +3. This is the answer. Now check out which one is the correct option. A is equal to 18 by 7, okay. B is equal to +2 and C is equal to +3. So for this question C is the correct answer. Now I'm going to rub this part and we'll discuss the next question. Wait for a moment. Now let's move to the next question. CONS3 hol 4 NO2 Cl shows which type of isomerism? First one is linkage isomerism. Yes possible, linkage isomers is possible definitely, because this is ambidentate ligand. If it is ambidentate ligand, then it can be represented like this, NO2, yes, then ONO, one times nitro and second time nitrito, O and N. Linkage isomer, clear. Geometrical isomers, then definitely if the component have formula Ma4B2, then it can show geometrical isomers. Here is also Ma4B2, yes, it shows geometrical. Optical isomers, no, there is no optical isomer is possible for this linkage. Now next one, check it out. Linkage possible. Ionization isomers, yes, NO2 has charges and this will exchange their ionization isomers is possible. So in this case what will happen? Linkage isomer possible, geometrical isomer possible, and ionization isomer is possible. So which is the formula? Linkage, ionization and geometrical. So C is the correct option. Clear to you? Linkage, ionization and geometrical isomery. This is the clear explanation. Now for optical isomers, we people know chiral center and plane of symmetry. We have to check it out. So in this case no optical isomerism is possible. Clear? 3 isomer: linkage due to the presence of ambidentate ligand, formula cis and trans is possible, A4B2 geometry, and octahedral complex because the coordination number is 6, and ionization also possible, but because their NO2 has charge, NS3 has neutral molecule, so ionization is also possible. So 3 main isomerisms possible: linkage, ionization and geometrical. Clear? I am going to rub this part and we'll discuss the next question. Wait for a moment. Now which of the following has 2 geometrical isomer and is also non-ionizable, that is no charge? As we know, if a complex has formula Ma4B2, now look at here, if I write like this, PT NH3 and Cl2 whole 3 and Cl2, this is not non-ionizable, this one is not possible. If I write here PT NS3 whole 6 then Cl4, no possibility to show geometrical isomers. If I write like this here, PT NS3 whole 4 Cl2, there is a possibility to show geometrical isomers. In this case similar, this pattern is similar, but here is this one is not non-ionizable. Ionizable, minus and plus charge are possible. If I write like this, if I put here PT Cl4 into NH3 whole twice, look at this is formula Ma4B2. If this is a formula of Ma4B2 and there is no such charges, then in this case what we observe, there is a possibility of geometrical isomer, one condition satisfied, and non-ionizable, not ion presence here. So in this case what is the correct option? C is the correct option. Clear to you what I am telling? We have to check 2 things, not only geometrical isomer, we have to check out geometrical isomers as well as non-ionizable complex. Non-ionizable, that is no presence of charge. So this option satisfy the whole criteria for these questions. Clear? Now wait for a moment. Now let's move to the next question. Which of the following cobalt complex is paramagnetic high spin complex? As if I talk about this complex CO and CO, C2O4 and CO, CN whole 6. Clear to you? What will happen in this case? Check it out. For in all the cases, that is, they form diamagnetic complex, not paramagnetic complex. What I am telling, they form diamagnetic complex. If I talk about COCN6, look at CO3 plus, that is the oxidation state, and the outermost electronic configuration is 3d7. Clear to you? Now for 3d7 what will happen? Check it out. 1 2 3 4 5 1 2 3 4 5, then 6 and then 7. Due to the presence of Cn minus, a strong field ligand, what will happen? Pairing will take place. If pairing will take place, then tell me what will happen. That is CO3 plus 3 electron, so electronic configuration is 3d6, not 3d7. Only put here that is 3d6. Now pairing will be done. What will happen in this case? Check it out. It can be represented like this: 1 2 3 4 5, 1 2 3 4 5 6. Now pairing, this will come here, this will come here. So in this case the hybridization is D2sp3, that is diamagnetic substance, no unpaired electron and low spin complexes. Clear to inner orbital complex. Similar here, one more thing. Clear to you? If I talk about CO, here cobalt is in 3+ oxidation state. For cobalt, in this case, what will happen? That H2O will work as a high strong field ligand. Due to this reason, again pairing will take place. If there is pairing take place, then we can say again it will form inner orbital complex, that is high spin complex and diamagnetic in nature. So which of the following cobalt complex is paramagnetic? High spin complex? None. So the answer of this question is none of this. Clear, friend? If you have any doubt, you can easily approach to me. I used to tell such words. Now wait for a moment. Now let's move to the one more thing. I have to modify this question here, put here 3, because cobalt in this option I didn't check in this option, that is CO. It will write X minus 2 into 3 oxalate ion, that is equal to minus 3. X minus 6 is equal to minus 3. X is equal to minus 3 plus 6. X is equal to plus 3. This is the correct order. This one minus 3 plus 3, done. Now you can say none of this. I have modified this because these are this form stable complex. So for this question, D is the correct option. Clear? Now let's move to the next question. The next question in this case is question number 5. Which of the following ligand is ambidentate? As we know, what is ambidentate ligand? Ambidentate ligand are those ligand which have tell me two donor atom, and at one time there is one donor atom attached to the central metal atom. In this case, this is ambidentate ligand. Clear to you? Here is also ambidentate ligand, and this one is also. But what is chelating ligand? That is best chelation. That is the case. It form the best ring structure around the central metal atom and will form a most stable compound. Look at the condition, chelation, ring type structure. So for this, D is the correct option. Clear, friend? What I'm telling? For this, D is the correct option. Now let's move to the next question, next section of the question. Question number 6. Which of the following pair of molecules have identical shape? Now identical shape, if I talk about NiCl4, xenon F4, a simple calculation by prediction we can say they do not have the same hybridization. But if I talk about Zn-H2O, so second option, check it out. Zn is in +2 oxidation state and the coordination number here is 4. If the coordination number is 4, either sp3 or dsp2 hybridization is possible. Yes, in Zn. And if I talk about H2O, H2O is, friend, that is the weak field ligand. Yes, if it is a weak field ligand, then the hybridization will be sp3 hybridization. Clear to you? What I'm telling? The hybridization will be sp3 in case of Zn-H2O. If I talk about SiCl4, check it out. What is the formula to find the hybrid? X is equal to 1/2 the valence electron here for silicon, that is 4, and monovalent atom is 4, that is 4, 4, 8, 8/2 is equal to 4. So hybridization is sp3. What we find here, that is in case of Zn-H2O whole 4 and SiCl4, the hybridization is sp3 in sp3. If I talk about the first option, Ni is in +2 oxidation state. Am I right? Ni is in +2 oxidation state. So it can be represented like this: 3d8. Check it out. 1 2 3 4, 1 2 3 4 5. Clear? Put here 1 2 3 4 5 6 7 8. Okay, now for NiCl 4 plus there is also a sp3 hybridization. Yes, because Cl is a weak field ligand. Now check out the XeF4, that is xenon tetrafluoride. How to write the how to find the that is hybridization. X is equal to 1 by 2. What is the valence electron? 8 plus 4, that is 12. 12 upon 6 is equal to 6. If the value of X is equal to 6, then the hybridization is for sp3d2, not sp3. So for first option, the one has hybridization sp3 and the second one is sp3d2. So first is the not correct option. And if I talk about ZnH2O whole 4 and SiCl4, then here is sp3. This is a single option type question. We do not need to check other option also, but if I check other option, then you can easily solve. Again, if I talk about FeCO5, then definitely it has hybridization. Tell me, it has hybridization sp3d, because this is coordination number is 5. Now if I talk about XeOF4, check it out. X is equal to 1 by 2, 8 monovalent atom 4. This is divalent, will not talk. Monovalent atom 4, that is again the hybridization is sp3d2. One is sp3d, the second one is sp3d2. So this is also not a correct option. Clear to you? If I talk about AgNH3 whole twice, here the coordination number is 2. If the coordination number is 2, then what will happen? So hybridization is sp. If the coordination number is 3, then the hybridization will be sp2. If the coordination number is 4, then the hybridization will be either sp3 or dsp2. If the coordination number is 5, then the hybridization will be sp3d or dsp3. In this case, we write sp3d or dsp3. According to the ligand strength, we will write inner orbital complex and outer orbital complex. And lump sum, we write here for FeCO5, if the coordination number is 5, either it will form sp3d and or dsp3. Clear to you? But if I talk about XeOF4, the hybridization is sp3d2. If I talk about AgNH3 whole twice, the hybridization is sp. If I talk about SF2, X is equal to 1 by 2, sulfur has valence electron 6 plus 2 4, that is 6 plus 2, that is X is equal to sp3 hybridization. Yes sir, here sp3, here sp. So this is not a correct pair. So only one option, B option, has sp3 and sp3 hybridization. Clear to you? So for this question, B is the correct answer. Now friend, wait for a moment. I am moving to the next question. Sometimes I give the detailed solution, but for such question you can easily solve. Don't move towards the detailed solution because it is complete time consuming, and in competitive examination we have less time. We should be very frequent to answer the question easily, because I have discussed all the things in my lecture. If you follow my lecture, then definitely I promise you, you can easily solve such kind of question. Same repetition is going on. So best to first of all follow my lecture, then solve this question with your own. Don't check my answer. You just take the question and solve it. Then definitely you will solve it. And practice, as I told you earlier, the practice makes a person perfect. Clear friend? Now let's move to the next question. Now look at the question. In the composed COCl3 into 5NH3. I have discussed this thing while discussing the Werner's theory, and according to the Werner's theory, do you remember two type of valency, primary and secondary valency? All Cl atoms so primary, not possible. 2 Cl atoms so primary valency and 1 Cl so atom secondary valency. 2 Cl atom so primary valency and 1 Cl atom so primary as well as secondary. Yes, this is the correct one, because the correct representation is CONH3 whole 5 Cl and Cl2. This is the best way to represent such complex according to the Werner's theory. Do you remember this? So for this, we do not need to check out all the option. C is the correct option. Clear to you friend? Now wait for a moment. here is some contradiction, don't get confused. 2 Cl atoms show primary valency, okay, and 1 Cl atom show primary valency as well as secondary valency. This is the just the elaboration of the topic, maybe. So this is the best explanation, and the correct form is like this. So we can say for this C is the correct option. Now next, let's move to the next part of the question. The next part, look at which of the following d orbital of metal is not the part of T2G set in octahedral complex. Tell me what will happen in this case, friend. So as we know, there are two parts, T2G and EG. Do you remember this? And with what is given here, so which of the following d orbital of the metal is not the part of T2G? Remember, so it is very simple. I am writing here. Is it visible to you? T2G. T2G, there is dx, dy, dyz and dxz. Remember, and for EG, tell me dx square, y square and dz square. Now please help me how to solve. This one is xy, xz and yz that belong to T2G, and the question is we do not belong. So this one is the this is dx square minus y square. Dx square minus y square belong to EG, not T2G. So for this question we people say, sir, this is the correct option, that is D, because dx square minus y square belong to EG. Now let's move to the next question. Now the question number 9, what will happen in this case? Check it out. Select the most stable complex. What is the in this case, first of all, for stable complex, for such option, first of all check the option. Here one is monodentate ligand and second one is bidentate ligand. If there is a bidentate ligand, then definitely there is a possibility to form chelation. More the chelation, more is the stability. As I discussed you earlier, what I am telling, more the chelation, more is the stability. In this case, there are more other things to stability, as I discussed. As a higher the value of K, we have to also check the value of stability constant. Then we have to check which type of complex attached to the central metal atom. There are various types to show, but in this case, that is one thing. That is, one is monodentate ligand and second one is bidentate ligand. In first case, there is only monodentate ligand. In second case, there is attachment of two bidentate ligand, EN2, ethylene diamine. And in this case there is one, but in the last case there is 3 EN, that is 3 bidentate ligand are attached. If there is, as I told you earlier, if there is more attachment of bidentate ligand, then more chelation, more is the stability. So in this case, due to the attachment of 3 bidentate ligand, this complex is most stable complex. So for this question, D is the correct option. Clear? Now friend, I am going to rub this part and we'll discuss the next one. The next one is, look at, for an octahedral complex, which of the following d-electron configuration will give maximum CFSE, crystal field stabilization energy? And for octahedral complex, tell me what is the value of CFSE? So 0.6 into x square minus 0.4 into y square. This is the formula. Now as I told you, D6, then what will happen in this case? That is high spin D6. Then tell me, yes sir, we are going to tell you, wait for a moment. Now use colorful chalk, 1 2 3 4, wait, this is 2 only, EG, T2G and EG, okay, 1 2 3 4 5 and 6. Clear? Now check out the electron 0.6. So for this CFSE value is 0.6 into x square, that is 2 electron, 2 to the 4, and minus 0.4 into 4 electron, 4 square, that is what will happen in this case 0.6, 2.4, that is minus 6.4. Am I right? Sorry, that is not x squared, that is 0.6y. Wait for a moment. 0.6, 0.6 into 2 minus 0.4 into 4. Clear to you? This is the formula, not y square. 1.2 minus 1.6, that is minus 0.4 in this case. Clear? Now for low spin d5, for low spin d5 first pairing will be done. I'm moving here, look at. For d5 it can be written like this, look at 1, 2, 3, that is 1 and 2. Now put here 1, 2, 3, then is 4 and that is 5. This one is easy and this one is T2Z. What is the value of CFSE in this case? 0.6 into 0 minus 0.4 into 5, that is minus 2 here. Clear to you? Now next one, low spin d4. If I talk about low spin d4, then what will happen? So pairing will be done first, that is easy, and this one is T2Z. This one is easy and this one is T2Z. Put here 1, 2, 3 and 4. So what is the value of CFSE for this case? I am moving here, friend, for this 0.4. For D6 we get minus 0.4. For D5 we got minus 2. For D4 we are getting this, that is 4, that is plus 0.6 into 0 minus 0.4 into 4, that is minus 1.6. Okay. Now for D7, that is high spin D7. Okay, no issue. For D7 high spin, first singly occupied like this. This one is easy and this one is T2G, T2G and EG. Clear? Now what will happen? 1, 2, 3 and 4, 5, 6 and 7. How many electron are there? 0.6 into 2. Yes sir. Minus 0.4 into 2 to 4 and 5. 5 electron, that is plus 1.2 minus 2. That is minus 0.8. Clear? Check it out. 1, 2, 3, 4, 5, 6, 7. So for all D6, D5, D4 and D7, which one has high value of magnitude? If I talk about D5, that is it have high magnitude 2. So in this case, which will have high maximum, give maximum CFSE, that is for D5, low spin D5, high spin D5, high spin, what I am telling, that is first of all singly occupied but low spin, first paired, then will move to the next from T2Z to EZ. Clear to you? Now friend, I am going to rub this part. I think now you can easily solve such kind of question. So we review the answer again. Wait for a moment. Now check it out what I am telling. Now for this question, tell me what is the option. This is one of the best question. C option, plus 18 average oxidation state plus 18 upon 7. For B plus 2 and for C plus 3. Now for CONS3, as I told you, it's show linkage isomer, it can show ionization isomer, it can show geometrical isomer A4B2, but optical isomer is not possible. There is an involvement of plane of symmetry. Now let's move. Which of the following has two geometrical isomer and is non-ionizable? As we non-ionizable, no charge. This is the correct option, C. Now let's move to question number 4. Which of the following cobalt complex is paramagnetic high spin complex? As I told you, none of. All are diamagnetic and low spin complex. So for this question, D is the correct option. Question number 5. This one form ambidentate as well as chelating ligand. D is the option. Now Which of the following pair of molecule have identical shape? As I discussed, ZnH2O whole 4, B is the correct option, sp3 and sp3. For question number 6, in the composite of COCl3 into H2, Werner's theory, I have discussed the same example. So in this case, C is the correct option. Now question number 8, T2Z contain dxy, dyz and dxz, not dx square minus y square. So for this, D is the correct option. Now let's move to the question number 9. Stable complex, more the chelation, more is the stability. In this case, there is 3 bidentate ligand and it will form ring structure. Due to this reason, D is the correct option, and that is CO and En whole thrice 3 plus form a stable complex. Now question number 10, for an octahedral, which of the following? That is, as I told, I have derived the complete calculation. That is -2, that is the magnitude for low spin, that is 2, maximum magnitude of CFSE. So B is the correct option, low spin D5. So friend, I think now you are very much familiar with such type of question. Practice it. I think it will help you a lot. So this is the last question for this class. We will meet you again. Thank you so much.